Hey guys, hope you had a good spring break. The next unit we're going to get into is wave. So I'm going to segment the lecture videos into a few different parts, so don't feel like you have to, sit through all of them and take notes at the time. You can space these out. So the first thing we'll talk about are characteristics. So what waves are, the two types of categories of waves, and then how we measure those. So a wave is just a rhythmic disturbance that carries energy through matter or space. And generally, this depending on the wave, waves require a medium. So, in other words, a material through which a wave can transfer energy. It could be solid, gas, or a combination of those things. Later, we'll discuss how electromagnetic waves or visible light waves, UV rays, do not require a medium or matter to travel. So waves carry energy, and waves are also caused by vibrations. They can do work and they can move objects. So when we're talking about energy in relation to waves, waves carry that energy. So a vibration is basically, it's the transfer of energy. So as waves carry energy, the particles in the medium move, and the direction of the motion will determine the type of wave we're talking about. So there are two types or categories. You have mechanical waves and electromagnetic. So mechanical waves, they have to have a medium. So some kind of solid, liquid, gas, or a combination of those to travel through. Mechanical waves cannot travel through a vacuum, so they can't travel in space. Examples of those would be sound waves, ocean waves. So think about if you're out in space, you have to have some kind of form of communication via radio to talk to whoever's in the spaceship, because sound cannot travel through space, but light can. So visible light, UV rays, because they do not require a medium. So they can be transferred vacuum. So the two types of waves are longitudinal and transverse waves. So a transverse wave, it's going to travel perpendicular to the direction of the wave. So think about holding a slinky and you are causing it to move up and down. Now, even though your direction is left or right, the wave itself moves perpendicular or up and down. So think water waves, electromagnetic waves do this. So the wave anatomy of a transverse wave, there are a couple or several different terms here. Your amplitude is always going to be measured from the crest, which is the highest point of the wave, to we call the light line here rest position or equilibrium. So the amplitude is how high the wave gets from crest to rest position. This bottom part here, the nodes is just where your wave crosses the rest position. Wavelength, we measure it from crest, or wavelength can also be measured from trough. Trough means lowest point wave. And of course, your amplitude corresponds to the amount of energy that's carried by the wave. So longitudinal waves, we also call those compressional waves, because in a longitudinal wave, you do have areas where the wave is compressed. So the medium moves in the same direction as the wave's motion. So examples would be sound waves. If you hold a slinky and you just push the slinky forward, the wave travels in that same direction. So the wave anatomy of a longitudinal wave is going to have these points of compression where the wave is close together. And they're going to have points in the wave where you have a rarefaction, just where it's pretty spread out. Now, wavelength in a longitudinal wave is usually measured from into compression or from rarefaction to rarefaction, which is up top. And just like with the transverse wave, the amount of compression corresponds to the amount of energy, which is your amplitude. Now, to measure those waves, one of the things we talk about is frequency. So that's just a number of waves passing a point per second. And the SI unit for frequency is hertz. So capital H, little z. So the shorter your waves are, the higher the frequency. So if you compare these waves, the second one here has a wavelength, meaning the waves are kind of closer together, therefore higher frequency, which means higher energy. So you can see with this point here, there are 2 waves passing this point where you have 3 waves passing this point. Therefore, the second wave has the higher frequency. Now, frequency formula for this is 1 over your period. Period is just the amount of time for one cycle to do a complete motion. That's all a period is. So period of time. Now we can also measure the speed of a wave. So velocity is the speed of a wave, or speed of anything really. Speed is forward, depends on the wave itself and the medium it's traveling through. But generally, the formula for the speed of a wave is velocity is equal to your wavelength, which is this little weird upside down y, times the frequency. So, determining the speed, solids, the molecules in a solid are pretty close together, so your waves can actually travel very quickly. In a liquid, the molecules are a bit farther apart, they pass one another, so the waves don't travel as fast. But then in a gas, molecules are very far apart, so a molecule has to travel far before another molecule. So that's why waves travel slowest in gases. Just as a few practice problems to look at, in honors, you'll see this in your task cards assignment on Tuesday. Here's an example. So find the velocity of a wave in a wave pool if its wavelength is 3.2 meters and its frequency is 0.6 hertz. And for velocity, we're given wavelength, we're given hertz. Just as any other formula we can plug in or cover what we're looking for. I use a little smiley face to cover up my velocity. So velocity is just wavelength times my frequency, and my speed this particular problem was 1.92 meters per second. Velocity is always measured in meters per second. Another example, an earthquake produces a wave that has a wavelength of 470 meters and travels at 5,000 meters per second. So we're given wavelength. Here we're also given speed, and it wants us to find frequency. So I'm going to cover up my frequency f, and I'm going to do velocity divided by wavelength, and you should get 12 hertz.